All right, so today we are working on lesson 2. All of your learning objectives are on the board. Probably can't see them because of the light, but I will read them. So in lesson 2, we're talking about using the number line to model the addition of integers. Sounds fairly easy, I think so. Here are the learning objectives. 1, students model integer addition on the number line by using horizontal arrows. For an example, an arrow for -2 is a horizontal arrow of length 2 pointing to negative directions. 2, students recognize that the length of an arrow on a number line is the absolute value of that integer. We'll get into that. And then 3, students add arrows, realizing that adding arrows is the same as combining numbers in an integer game. Given several arrows, students indicate the number that the arrows represent, the sum. All right, so what am I talking about? Let's get right into our work. Do me a favor, gentlemen. Sit up. Thank you. Classwork. It says, exercise 1, real world introduction to integer addition. Answer the questions below. A, suppose you receive $10 from your grandmother for your birthday. You spend $4 on a snack. Using addition, how would you write the equation to represent this situation? Now, before you do that, let me switch my, there we go, so that we can see the board. Okay. So how will we write this as an addition equation? And we're talking about exercise 1A. Somebody help me. Danny. Huh? Is it 10 minus 4? Let me read it again. Suppose you receive $10 from your grandmother for your birthday. You spend 4 on a snack. Use addition. Using addition, how would you write an equation to represent this situation? So 10 minus 4 would be, it would be correct. However, we're looking at negative numbers and we're talking about integers. So if I wanted to write this using a -4, how would I write that? Yes.
You put 10.
Okay.
Subtract, is it?
Nope.
10 plus.
Okay.
You have to put this in parentheses. -4
Yes.
equals.
So I will write this like this. So how much would I have left? This is easy math right here. $6, right? So A, that's how I will write that. So please do so on your papers. And let's look at B. It says, how would you model your equation on the number line to show your answer? So they give you a number line. And I'm going to say this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is -10. This is +10. How will we model this equation on the number line, Danny? Huh? Ashanti. Why do I keep doing that? I'm going to get it together. Keep correcting me. What would I do?
You have to start at the 10.
Start at the 10. And then what do I do?
You subtract 4.
I subtract 4.
Or you go back 4.
Do I go back 4 or?
4 to the left.
Okay. Right there, right? Mm-hmm. Is that it? And that's all I have to do, correct? Mm-hmm. Very simple. Anybody got any confusion with that? Just that part. Any confusion?
It's as simple as Y.
All right. If there is no confusion, let's jump down to example 1, model in addition on a number line. I'm going to call this M, okay? So that we don't get it confused. Alright, so it says complete the steps to find the sum of -2 plus 3 by filling in the blanks. Model the equation using straight arrows called vectors on the number line below. So let's look at this. A, place the tail of the arrow on what? Now you might be confused as to what I'm talking about. Let's pretend
On the line.
we can use this number line. We're trying to show -2 plus 3. Where am I going to start? Huh? I can't hear.
She said 0.
0. 0 is correct. So A will be 0. That's where I'm going to start. So I'm going to place the tail of this arrow on 0. That's where I'll start. Draw the arrow 2 units to the left. And you can do this using that number line up front so that you don't get confused. The number line on your paper, use that. Draw the arrow 2 units to the left of 0. And stop at, where are you stopping? -2. Yes. The direction of the arrow is to the left. Yes. It's to the left since you are counting down from 0. Let's look at C. Start the next arrow at the end of the first arrow or at what?
0.
Nope. Where did you land? -2. Yes. Just like yesterday when we went over the steps when we drew the cards and then you start there. ID. Draw the second arrow. How many units to the right since you are counting? 3. Yes. I'm sorry, I said E. F. I said F is E. And then you're going to stop at what? 1. So, sometimes we don't need, a lot of you guys, have to go through and say, oh, I need a calculator. You don't need a calculator when you're answering questions like these. When you see the addition, you can use a number line if you never have a calculator. Those are just some things that you can use. All right, so let's look at F. F says, circle the number at which the second arrow ends to indicate the ending value. What number are we circling on this number line? 1. Please do so. Y'all see just how easy this lesson is? I know, it's easy. All right, so let's look at G. Represent the process from parts A through F for an expression 3 plus a -2. So, what they want you to do, in F here we circled 1. I'll put that down. Circle 1. For G, they give us a number line. That's 10. -10, and they say, repeat the process from parts A and F, A through F, for the expression 3 plus a -2. So they actually want you to do the steps for 3 plus a -2. So we start at 0, we move over to 3, plus a -2 will give us 1, 2. Just like that. And notice that we went this way first and then that way. That is exactly what they want you to draw on that number line for 8. And we land at 1. So you can circle that 1. H. What can you say about the sum of -2 plus 3 and 3 plus -2? Does the order matter when adding numbers? Why or not? Is it the same or does the order matter?
The order matter.
Huh?
The order matter.
Okay, so let's check it out. She said the order matters. So let's look. So we got -2 plus 3 equals, and then we got 3 plus the -2. What is -2 plus 3? Huh? 1. What's 3 plus the -2? Does it matter? No, it does not, because it is the same. So you would say the order does not matter. When adding, make sure you say when adding numbers, because the order does matter when you're doing division and multiplication. So make sure you say when adding numbers. All right, moving right along, if we can. Any questions with this example that we just did? Anyone confused? Any questions? Say so now. All right, let's look at example 2. Example 2A. Okay, it says, how does absolute value determine the arrow length for -2? Use the number line to provide your space. Now, don't write this. I'm going to show you what absolute value. Did we talk about absolute value yesterday?
Yes.
I believe we did. I told you that the lines look like so, with a number in the middle of it.
Yeah.
Okay, so that means absolute value. And the absolute value can never be what? The answer can never be what? No? Think about what I said yesterday. Absolute value, the answer can never be, huh? It can never be a negative number. Absolute values can never be a negative number. Now, this is what I need y'all to understand. This is what we talked about yesterday. You have to remember this stuff. If I were a child in this classroom, I probably would be taking notes on things like that. I probably would have a notebook and I take notes on things like that. Absolute value can never be negative. So the next time I ask that, you have it and you know the answer. So let's look at A. Now that you know that, it says, how does absolute value determine the arrow length for -2? So that means that we have -2, and we're trying to find the absolute value. What is the absolute value? 2. That's how many times from this -2 do we get back to the 0? 1, 2. That's the absolute value. It's 2. So the arrow is 2 units long. This is the question they asked, so you have to write this. The arrow is 2 units long. Because -2 is the negative number, the arrow points to the left. All right. Any questions on that one? Let's look at B. How does the absolute value determine the arrow length for 3? Use the number line to help you. So now we have the absolute value of 3. Anytime we say absolute value, we have to put those lines. Okay? So what is the absolute value of 3?
3.
3. Therefore what? Therefore what?
The arrow is
Oh, the arrows.
The arrow is 3 units long. That number line that is on your paper is there to help you if you're unsure. C. Describe how the absolute value helps you represent negative 10. So the absolute value of negative 10 is,
10.
which means
The arrows changes.
the arrow is 10 units long. Correct. Any questions? All right. Moving right along then, if we have no questions. Exercise 2. Exercise 2. And we're looking at A. Now, they want you to do the number line, so I'm not going to do it on here, but you do it on yours. Negative 6 plus 4. So if I'm starting at 0 and I go to negative 6, I'm going to add 4. Do that. Show me the arrows or loops, whichever one it is. And where do I land? Negative 2. Excellent. Look at the next one, 3 plus a negative 8. Again, do it on your number line. You're going to start at 0, go to 3, and you're going to go left 8. Where do I land? I heard it, negative 5. Not 5, but negative 5. If you land on 5, you went backwards, the wrong way. Any questions with that? If there are none, let's go to example 3. Or exercise 3. Find the sum of the integers represented in the diagram below. Okay. So the first one says, A. Looking at what they gave us on the number line. Write an equation to express the sum. Someone give me the equation. Where do they start? Where do they go?
5.
Tristan, okay, come on. 5.
5. Quotation marks.
Mm.
No, minus
Plus,
plus negative 2.
okay.
Minus 3.
Plus 3, yes. And where do they land?
6.
6. Excellent. Does everybody see that? Anybody confused? You can look at the arrows and see where they pointed to. All right, let's look at B. What 3 cards are represented in the model? And how do you know? You remember yesterday when we flipped the card? And then we moved another card, but we didn't actually flip the cards, but the cards were on your paper. What 3 cards are on that number line? 5,
5,
negative 2, and 3. Easy. And then it says, how do you know? Because the arrows show their length, okay?
With the interruption, Miss Sally, can you please call me at 5220? Miss Sally, 5220. Thank you.
So please make sure to write that. Because the question asks too. How do you know? All right, C. In what ways does this model differ from the ones we used in lesson 1? Anybody know? Yes, Jerry.
We're doing triple as a double.
Well, not quite. And the lesson beforehand, what do we do? In lesson 1, a movement of 5 units was shown with separate hops. What's the difference with this level?
There's more.
Nope, look it. The one yesterday, we were hopping. Are we hopping this lesson? What are we using? We are using straight arrows this lesson. So in this lesson, you can see it. It's not a trick question. We are using straight arrows. Instead of hops. Okay? All right, let's look at D. Can you make a connection between the sum of 6 and where the third arrow ends on the number line? So where is the final position of the third arrow? 6. So this means that the sum is 6. The final position? You writing what I'm writing? Of the third arrow is 6. So this means the sum is 6. Last one. Again, it says the final position of the third arrow is 6. This means the sum is 6. And sum, when I say the sum, I mean the answer. All right. It says, would the sum change if we change the order in which we added the numbers? For an example, if we said -2 plus 3 plus 5, will the sum change? No, it will not. We will still land on 6. And the reason why is because addition is commutative. You should have, what do I mean by commutative? When you are in, I want to say, so the order does not matter. So what do I mean by that? When you were in, I want to say, probably 3rd grade, you learned about commutative property. That's what that means. So in commutative property, it does not matter the order of the numbers. The answer will stay the same. So now you guys have your exit ticket, and there, same thing we were doing on here. Those that are at home, you will work on your exit ticket, and you also will work on your problem set. Please answer those questions in the Google Doc and turn that in by the end of the day.